Royal Society was the brainchild of some key intellects, great thinkers like Robert Boyle and Christopher Wren, and these were the key architects at the inception of the Royal Society. But not only of the society, but some of the fundaments that we still appeal to when trying to understand who we are.
A lot of the questions that people were interested in during the founding of the Royal Society, people are still fascinated by today. How can information come out of solid matter? And I think we're now equally puzzled by how consciousness of our own information, consciousness in the brain, can come out of this lump of jelly.
We are who we think we are. There are certain perspectives on brain function that suggest that we are the author of our own environments. And if that is the case, then very much we will behave as we expect ourselves to behave. If one imagines the brain as a very large and complicated onion, on the outside we have the parts of the brain that are exposed to sensory input. But as you go deeper and deeper into the hierarchy, those deeper levels are now generating top-down predictions to be tested against beliefs in the outer layers. So a little baby will spend most of its first few months just working out what it can influence and move and what it can't move. Once you've done that, though, then you can select the data and the constituents of your own model. That's just a very technical way of saying we are curious beings.
One of our key characteristics as humans is our curiosity, and I think the Royal Society reflects that people were coming together initially in a club in the 17th century to discuss science and to really think about the most puzzling questions of the time. And of course they read each other's work, and that was terribly important.
So this is the celebrated Boyle's list, written in the 1660s. And a wonderful list of aspirations at that time.
So I can see the prolongation of life, the restoring of youth, or at least some forms or marks of youth. That's good enough. So like having new teeth or hair that's coloured as if you were young.
It's very pragmatic.
It's very nice. You don't actually have to be young, just look young. And then the art of flying, lovely one.
It's also quite prophetic. I mean, we've got here the cure of diseases at a distance. I mean, of course, that's exactly what we do with the radiotherapy nowadays, non-invasive treatments for, say, cancer.
Potent drugs to alter or exalt imagination, waking memory, procure innocent sleep. So nice.
That's my favourite one. Of course, the most pertinent to the sort of work that we do, understanding chemical and drug-related transmission of signals in the brain. Of course, all the money that goes into pharma research, I think is a testament to the importance of that particular item on the wish list. This is marvellous. This is the inception of Bayesian thinking by the Reverend Mr. Thomas Bayes. Read November the 14th in 1763, lays a foundation for the way that we analyse our data.
How did that transform into an understanding of how the brain might be processing information?
The notion was that we as scientists have hypotheses or beliefs about the causes of the data that we go and garner in order to try and test those hypotheses. And in exactly the same way, it could be that the brain is in the game of gathering sensory data to test its hypotheses or models about how the world works. So that's a beautiful parallel between us as a collection of scientists and the brain as a collection of systems, all trying to test their own beliefs and their own hypotheses. And I can guarantee that in some of your data analyses, you will be relying upon the notions first expressed in these pages. What are the most fundamental aspects of the world in which we inhabit? The most obvious answer is the fact that I am me in a world that is also populated by other people like me. If that fundamental aspect of our egocentric world is not learned, that may be, in part, an explanation for autism.
One of the really interesting things about studying autism is that it gives you a different view on typical development and how non-autistic or neurotypical people are. There is something in autism that is very conducive to talent and to exceptional talent. People with autism seem to see the world at a level of detail that the rest of us miss. And we know that there are savant skills and special skills in music and maths and art and memory in autism at much higher rates than any other group. But of course, if an alien came down to Earth and looked at us, they would be amazed by the ordinary ability that we have to remember thousands of faces. So we're all savants too, but we're social savants.
Higher forms of animals, people like you and me, we have this capacity to model and have beliefs about the future. Usually there's a drive for a unified theory. You know, everybody wants to have one explanation. To get at that, clearly, all the scientists have to subscribe to the same hymn sheet. Of course, that's why there's so much focus on the art of scientific writing. What did you have to believe in order for you to say or write that? And that will change my beliefs.
I think it's very important that people understand that science is fundamentally creative. Although we have now at our fingertips huge amounts of information and data, unless you have the creative mind that can bring new theories in that Bayesian way, impose your exciting new theory on that existing data. Unless that happens, we don't move forward as a society, we don't move forward as scientists.